What is that, my tan? Oh my god. Like microscope vision. Alright. Why am I not playing with this? Look at that. Okay, alright. Like, who's writing that small? Like, what are they bringing those slides on microfiche or something? Like, jeez.
It's to inspect the crib sheets.
Yeah.
It could be that like they print out all the slides.
Yeah, they're just like moving it like. Yeah. Okay. The reason I brought the document camera up. Focus. Autofocus. Focus on. I'm trying, but anyway. There we go. Autofocus. Maybe if I turn my screen right this up. There we go. Hey. There she is. Don't applaud me, applaud my wife. You did a very good job. This is Cordelia.
Wait, her name is Cornelia?
Cordelia.
Oh, Cordelia.
Yeah. There you go. And this is the other one. But he doesn't count anymore. Yeah, having played with it that much, I am absolutely convinced of the superiority of chalkboards. Yeah, like, oh my god, like these things have to focus? Oh jeez. Oh yeah, and it also, requires more people employed to keep it working than a chalkboard, doesn't it? Hello, folks. The bureaucracy is expanding to meet the needs of the expanding bureaucracy. So, how's everybody doing today? I feel a little bit, with the microphone and everything, I feel a little bit more stand-up than I usually do. So what's the deal about airline food? Nobody likes airline food. Anyway, it's like one of the last remaining safe targets for a joke. But anyway, so were you recording? Awesome. So, when we were talking last time, we were talking on the subject of object-oriented programming. We were just about finished with that whole kit and caboodle. So, let's continue on. I'm trying the mic out today. I've never tried the mic before. We'll see how it goes. So, last time we were talking about the mean calculator. We did our sort of basic, naive implementation of the mean calculator. And then we did our new and improved version of the mean calculator. I see that's very dark, so give me 1 second. How's that? Better? Question? Could I switch to which? Light mode. What? You want me to switch? What? But dark mode is king. You can't switch away from dark mode. What about my poor eyeballs? You know? Having to soak in all of those excess photons. It's ridiculous. Anyway, and besides, this is more atmospheric, I think. So, yeah, I've just decided I don't like this thing, so I'm going to switch to the other one. I use my hands for gesturing. Test. There we go. All right, so, enough, settle down. I am going to still gesture with the microphone though. It's off though. So, we were talking about the mean calculator. We discussed two ways of going about it. This is going to be a very important concept when you guys get a little bit later on in your degree programs. Say, particularly once you start hitting second year algorithms and materials coincident with that, perhaps even earlier. We mean to decouple the means by which a program can be accomplished with the interface that the program presents to the outside world. In the case of Mean Calculator 1 and Mean Calculator 2, if you were just examining them from the perspective of what methods are available, what do these methods return, and what arguments do these methods accept, both Mean Calculator 1 and Mean Calculator 2 present the same interface to the world. That being said, both of these classes go about implementing things in very different ways. In the case of the first one, we are storing everything that we need, every piece of input that we have ever received, into a giant list. So this is using, shall we say, a memory complexity equal to the number of inputs this thing is expected to process. Whereas the second version uses a constant amount of memory no matter how many inputs it wants to take. Therefore, we would say in terms of memory complexity at least, this thing is a lot more fast and good than the first version. Not just memory complexity though, also in terms of runtime. The first version, which the end is hanging out there. Here we go. So the actual calculation which is being performed to calculate the mean requires the call to sum and length. Now the length of the data structure is information that will be kept in that data structure's class. You can just look it up. It doesn't actually have to count them. It just keeps track of how many is in it and stores that in an auxiliary variable. However, the sum of all of the elements of a list, that's something that needs to be computed and is computed anytime you invoke the sum function. So, how many steps does it take to sum n items?
N plus 1.
Right. Well, although we do say, like, proportionally it's n, right? So, because this summing operation is proportional to the size, to the number of inputs that the class has received, we say that this is a linear operation. Whereas, in the other example, we have performed the sum every time something has been added. So, asking the class what its sum is itself is a constant time operation because all it is arithmetic on two existing variables. Make sense? Now, we do run into, it's not like mean calculator 2 is purely a constant time algorithm. It does, you have to factor in that you are required to add these things one at a time, right? So, in order to populate the mean calculator with n items requires n steps, right? But in general, this is, not nearly so bad as requiring it to go through each one every time it requires the mean. One may make some arguments about how frequently things are added to the data structure relative to the number of times the mean operation is required. You can do a kind of a stochastic analysis that way. And in general, so long as the append operation on the list itself isn't a linear time operation, so long as that's a constant time operation, we can say that add is still reasonably, fast. It's a reasonably good algorithm. Now, we do pay a price, right? I think I mentioned it last time. Does anybody remember what price we pay by gaining all of these runtime nicenesses? Anybody? Yes, sir.
The program is less versatile, so you can't add other functions that use the list given.
That's correct. The program is less versatile because we are no longer keeping track of all of our inputs. One might think that for a standard statistical package, which this appears to be, if you wanted to expand it with any additional functions, such as median, mode, standard deviation, any of these sort of, standard basic statistical type calculations, the mean calculator 2 is not going to be useful to you, and it cannot easily be adapted to calculate something like mode, because you simply don't have that information anymore, right? This, in a very real way, is the essence of optimization, and this is the essence of algorithmic optimization in particular. Whenever you are creating a more optimized version of an algorithm, normally you are stepping from a more general form to a less general form, and by that step from more to less general, you are throwing some information away that was keeping you back, that was requiring time to process. So, unless, of course, you're just a bad programmer, in which case you can probably optimize your code without having to worry about, how much information you're keeping track of. You just sort of, learn that you don't have to use 6 nested while loops to do the thing that you could do with 2 and stuff like that. But, question?
Then, if you program for certain programming or something like that, do we use mean calculator 1 or do we use 2?
So the question is, if I get you correctly, which one of these would we use in practice? Right? No?
If you program for certain program, would you just choose which one would you program first? Would you just program first in general, and then later if you have to make it optimized, then you change it to 2? Or do you just
Yeah, so that's a good question. So this is a question about process. So if you were presented with a coding task, and would you start with the more general version, and or would you start off at the more specific version? I would say, generally speaking, so to speak, it depends on your level of experience. If you're a person who's well versed in the type of coding that if you're well versed in the area and you've done these types of algorithms in the past, it's entirely likely that you'll be able to jump immediately to the more optimized solution. That being said, the general version, while taking more time, will also be, shall we say, more likely to be correct, right? Because in this case, you're just trying to do a sort of brute force bare implementation of the specification itself with no additional, no additional concerns, right? So you're focused on correctness. The correctness is more likely to come out, right? In Mean Calculator 2, you are adding an additional concern, which is optimization. The advantage of having done the generic version first is that you have something to check the correctness of the optimized version against. So it can be very useful to have both versions, right? You can imagine there being some kind of an optimization that's so optimized you are not necessarily convinced that you're getting the correct results anymore, right? It's useful to have another program, even if it's a lot slower, to be able to generate test cases, right? Does that make sense? Good. Any other questions? That was a good question. Yeah. Don't worry too much about optimization until second year. But once you hit second year, you should start worrying about it. Good. Yes. So, functions provide algorithmic abstraction. Functions can be used without knowing the details of the algorithm they implement. This is, again, part of our long-running theme of abstraction and modularization. Code should click together like Lego pieces. You shouldn't have to think about, how the plastic tines are constructed on the underside of the Lego in exactly such a manner that they provide exactly the correct tensive force between the peg on the top and the tines on the bottom, so that there's enough friction that the bricks stick together, but not so much friction that once together you need excessive force to remove them. You don't have to worry about all of that. You just have to think brick, bottom, top, click, done. That's what you want your software to be like, right? So where functions provide this type of abstraction for pure procedure, classes provide this type of abstraction for procedures and data, right? A lot of the instances where you may have been tempted to use global variables to share data among many functions, what you were actually thinking of was classes, but you didn't realize it, right? Because that's essentially what a class structure is like. It's like you have a group of functions that have a certain number of variables that they share. With respect to the functions inside the class, those variables look like global variables. But because everything is encapsulated in the class, we don't have to worry about all of these problems that we run into with global variables, at least not to the same extent. Make sense? Good. Data abstraction of classes assumes that attributes are not manipulated from outside the class, which is why it's a terrible assumption in Python. Nothing actually prevents outside functions from accessing and modifying the contents of member variables. This can lead to an inconsistent state. So, I will try to keep tonight, I will try, it's the microphone. I feel like I'm a late night talk show host. We are in this particular context, right? I'll try to keep the Python bashing to as short as possible, but inside of like other object-oriented systems, you have a strong distinction between variable, like private and public variables, right? A private variable is one which may not be modified outside of the class in which it is incident. A public variable is a variable which may be modified outside of the class or outside of the object to which it is incident. In general, in most object-oriented languages, the creation of member variables outside of the class is disallowed for obvious reasons. In Python, for some reason, it is allowed. So if you have the mean calculator function, or the mean calculator class, let's just say you had an object of that class, right? And you wanted to add some variables to it, not by modifying the class definition, but by modifying the object itself. Python practically encourages you to do it, which is, of course, contrary to the entire idea of modularity and one of the reasons why Python is a terrible language. Another reason why Python is a terrible language is the manner in which it handles private membership. Now, Python does have a concept of private versus public members. In Python, if you prefix any member with a double underscore, just the prefix, not on both sides like EQ or string, that is what designates a variable as being private. In the same way that all member variables in a Python class must be prefaced with self dot. You have to get to them through by referencing self and then using dot syntax. In the same way, anytime you want to access or reference a private member in a Python class, and this can only be done within the class, of course, you have to prefix the variable name with 2 underscore characters every single time, because Python doesn't allow you to declare data types, or it didn't anyways, and this has to be compatible with that for some reason. So you can't just declare the thing to be private up front, and then it's just private, and you don't have to worry about whether it's private or not the rest of the time you're using it. In Python, you have to put the characters in, otherwise it's not private. So what happens if you forget these underscores and you just code up like X, and like you have a private X and you accidentally just do X without the underscores? What does Python do? It creates a new one, which is public, with the same name. That's right, and this works from outside of the class as well. So if you, as a programmer, are using an object in Python, and you're trying to access, like, you don't know it's a private variable or something, and you try to access X, it will let you, but it will create a new variable with the same name, but this one's public instead of private because everything's loaded into the bloody identifier. I'm not going to ask if that one makes sense. I normally ask, does that make sense? In this case, I think we all know that doesn't make sense. Nevertheless. Is anybody offended? Like, can I get like some kind of feeling of like visceral hatred from Python from the class right now? I would love that. Thank you, thank you. Did you have a question?
So can you show me some example of just work, can you just try to be
Absolutely, yeah. I've talked about all this. Now let's actually show you. Now it's time for the horror show. So let's just say let's talk about mean calculator 2. There's no particular reason why a person should need to access either the sum or the count variable, right? From outside of the class anyway. So let's make them private. Not only do we have to put our double underscores inside of the constructor, but every single place that the things are referenced at any point in the class, which of course means that if you want to, oh, I don't know, change a variable from a private to a public and then back again, depending on how long your class description is in terms of lines of code, you know, if I were to put it in algorithmic terms, the complexity of changing a variable from private to public is equal to n, where n is the lines of code in your class, right? Whereas in a sane language like C++, that's a constant time operation. Yes?
So what's the difference between this and, for example, C? Like C declares it as private before anything? Like when you declare it, you declare it as private and then stay private?
Yes, I'll modify what you're saying a little bit. C++, not C, because C doesn't have objects. C is not an object-oriented language. It is just an imperative language. It doesn't have classes or objects, but C++ does. And yes, basically the way that you would do things in C++ or Java or some other kind of sane language, you'd have something like, you know, private int s, private int c, and then you just use c and s anywhere they appear. You don't have to do self dot double underscore, you know? Every single place that it's used. Does that make sense? So that's what it would look like in a much better language. I have no idea how Python became so popular. Actually, I think it's primarily because it's like people who are only tangentially programmers like Python because they don't know enough about programming. So, but anyway. So we've got all of this going on, right? Let's say we had a programmer who just wanted to, give me 1 second. Sorry?
I think we missed the private, like, you know, double underscore in the mean.
Oh, yeah, I gotta put it in here too. See? You see what I mean? Do you see what I mean, sir? You're just gonna make mistakes. You're just gonna forget stuff. You know? Like, anyway. So let's just say, for the sake of interest, that we had a programmer who wanted to make a modification to S from outside because he feels that's his right and privilege, and anything else would be to impinge his sovereignty as a programmer. So, m.s, but let's see what happens when he tries doing this. Tries performing, first of all, let's just leave it at that, right? And then let's also see if we can, oh, I've got bloody cap locks on, or num lock. Gets me every time. All right, there we go. Let's see if we can view S. Yeah. So, you will notice what we actually hit is an exception. So here's another bloody thing, right? And you know, technically this is like a security thing. This is like, you know, when you get the username wrong instead of the password wrong, they still tell you the password's wrong or something. Like they just give you like a generic, oh, this doesn't match, because they don't want people to be able to probe to see what the correct usernames are and stuff like that. So it's kind of like a data security thing. But if you try to access a privately held member of a Python class, it will pretend that it doesn't exist. You will get an attribute error saying that this class doesn't contain that type of attribute. It's the same it's the same error that you would get if you tried doing something like obviously doesn't exist. And it wasn't private. Right? Same attribute error. So, so let's just modify that to S now. Oh, I've got to, if I'm going to do that, I've got to initialize it. Okay. You'll notice that you also don't have read privileges, right? So writing to private S didn't work. Reading from private S gives us the same issue. MeanCalc2 object has no attribute S, even though it does, so it's technically lying. If we remove that, you can see that what this line has actually done is created an S parameter inside of the class that is totally and wholly unrelated to the sum that this poor programmer thought they were modifying. And as such, despite the fact that we have added it 10 to S, obviously that doesn't have any effect on the mean as calculated. Because why would it? We're not referencing some public S variable. We're not referencing that inside of our methods, because why would we? So here comes the kicker, though, right? You can also do this with functions. So the methods themselves can also be modified from outside of the class. Did I tell you about that exploit that one of my students found that broke the autograder? Yeah, that was the problem, right? In case you skipped that class, last year we had, or a couple of years ago, some student publicly posted like 4 or 5 lines of code that meant that you would pass pretty much every test case in the course, because what they did was they wrote a very simple class which overloads equality comparison, right, to always return true. And then anytime anything was compared to it, it always returned true, right? So any test, any assert statement that used equality would always come out true, which meant that you didn't actually have to write the question, you just had to pop this thing in, return something of the correct thing, and there you go. And so, would we recommend Python as a language for secure internet applications? No. Do something with a goddamn type system. Ugh. Like, I know type systems are hard, and that people are stupid, and that people can't wrap their heads around what an integer is for some goddamn reason. But so many of these problems can be avoided if you just have a static typing system. Strong static typing. Good God.
Before you move on, would you like to see how it's hiding that private variable? Have you looked at it?
No, what?
If you just print out m.__date__, you'll see how it's hiding that private variable.
Okay, all right. Is this going to make me more angry?
Probably, yeah.
Okay. All right. So, what am I printing here?
Double underscore, m.__.
M.__.
As if you were accessing like a variable inside of m.
Oh,
Capital M.
M.__.
Single underscore first.
D-I-C-T.
D-I-C-T?
Yeah. Double underscore.
That's it?
Yeah, just print that.
Oh my God. You're one of those 3 guys on the internet who know a lot of Python, aren't you? maybe. I don't know. There were like 3 guys when the lectures were online who were like,
You see, it's just added the name of the class in front of that private variable.
It's just name angling. It's really annoying.
that's it?
It's
You
a
can
compiler.
still access that private variable.
All it does is the compiler looks for that and adds underscore the name of the class and then sticks the name after.
So you're telling me that if I do this,
Yep.
this will work?
Yep.
You're shitting.
No, I'm not.
All right. You guys, bye. All right. Yeah, okay, all right.
Wait, what, you modify that? Yep. You can modify it.
So this is full read-write access.
Yes.
And all you have to do is look up the dictionary, which you can easily, because it's a dictionary, and you can just get the secret code name of every private variable just by calling keys like dictionary.keys, and then you can just loop through them and set them all to this is why Python sucks. God, because they don't, you can set them to strings because of course it's Python. Why wouldn't you be able to? Please do me a favor, everyone in this room, and learn something about Python. We need, this, okay. This has gone from me hating Python to now me being on a righteous crusade against Python. We need to remove it. We need to commit holy war on Python. Yes?
I just wanted to point out how it's interesting how DICT has 2 underscores and yet you can still access it outside of the class.
Yeah, that's true. That's also true, isn't it? Despite the fact that this thing is also prefixed by a double underscore, I'm totally accessing it outside the class, aren't I?
It's only if you put it on the front of it. If the double underscore is only on the front, then the compiler tags it. If it's on both sides, it's one of the Dunder magic methods or attributes. Then it just stays the same.
Yeah.
You can
Yes?
Does Python just pretend to have private variables?
Yeah, it's just pretending. Yeah.
Does it really help?
No, this is what happened, right? Python is Python's like the 6-year-old on the playground that hangs out with all the 9-year-olds, and the 9-year-olds let him hang around because they think he's dumb and stupid and kind of funny. And he saw all of the 9-year-olds had private variables, and he's like, I'm gonna have private variables too! But he couldn't actually pull it off. That's what it is. My God. All right.
Yeah.
All right.
You can actually also edit that dictionary as
Yeah,
it is.
of course you can. Why? Why would you not be able to modify that? That's like, why wouldn't it be? Why would they have something like that and not write and just leave it open, not write protected or read protected? There's no reason to protect that type of information. That's just, again, that would just be to impinge on the sovereignty of the programmer. All right. Jesus H. Christ. So, I will reiterate, do we use Python for secure applications where we care about security? No. It's like even worse than SQL injection. Jesus Christ, at least, Oh. It's like a hacker's paradise. Jesus. All right. All right, the last few slides have Mario. So we'll have this fun exercise, and then we'll call it a day, and I'll go pull a Minecraft where I just dig a hole in the ground, cover it up, and just beat until the creepers are gone. So it should not surprise you to learn that most software applications in the modern day and age use object-oriented programming. Therefore, we can begin to think in terms of software. This is, once you learn how to code well, this is a thing, you'll never be able to play video games again. At least not in the same way, because you will be like Neo. You will see the Matrix. All right? So, I'm about to try to ruin you for Mario. So, let's consider classes. How might we take a typical game of the Mario, and how might we break this down into some classes? All right? Who wants to propose some classes that we might use for this game? Yeah? Collider class. Well, you're getting too complicated. Bring yourself down to the level of the class, please. Yes? Items, yes. Items like what?
The coin and the mushroom.
Coins and mushrooms. We might call them pickups. Right? But yes, sliders will obviously be a very, very common subclass that's used by pretty much everything that you can collide with. Yeah. Yes?
An entity.
Entity. That might be something like a good or a bad character, right? Fair or foul. We might have Goombas and piranha plants equally considered entities along with Marios and green Marios. Here's a question. Is Yoshi a character or a pickup? Is he an entity? Yeah.
Did you say Yoshi?
Yeah.
Yes.
You think he's an entity?
Yes.
Yeah. But he's not a pickup or an upgrade while you're on Yoshi. He's just a rendered Yoshi object. Like, he's just a rendered Yoshi up, you know.
And what is the policy?
So that's also just, that's, it. So if you imagine the character as having a number of sub-objects which are the various, like, rendered outfits and that sort of thing. Like, a class can swap between the different renderings reasonably easily. It's kind of like, if you consider the winged Paragoomba, right? This is the Goomba, which is also inheriting wings from, like, whatever wing class, and, you know, the model for the wings is kept elsewhere. It acquires them, puts them in a particular position. If you notice, the wing as rendered on this Goomba is actually precisely the same wing as rendered on the Koopa, right? Like, the model is actually the same model. The only thing that's different is the positioning on the character, which is, of course, good design. So we've talked a lot about characters. Incidentally, my opinion on the existence of Yoshi, I don't think Yoshi exists, except he exists in the same way that the mushroom exists. He's a pickup that can only be interacted with from one direction, which is to jump on top of it, whereas most pickups you can get from any side, right? So he's a directionally restricted pickup item, which causes a rendering change in the player character and the addition of some, some attributes, including, tongue attack, etc. Right? That's my opinion, but you're welcome to have your own. Yes? Okay, but now you gotta restrict what an entity is, right? So I would say, right, in order for it to count as an entity, all of this is arbitrary restrictions, but for me, I would say in order for it to count as an entity, it has to have some kind of, like, damage relationship, right? Like, players can be damaged. Non-player enemy characters can do damage. There needs to be some kind of damage relationship between the two. Because you can't say that Yoshi is an entity just because he, interacts with the physics, because the mushroom also interacts with the physics, right? And if it's a pickup, then why isn't Yoshi a pickup? So are mushrooms entities? That's the question. Yes?
So, like how the propeller suit becomes like a property of the character when they get to pick up the propeller suit, does Yoshi just become a property of like the player?
I I would argue that that's what's going on in the back end, yeah. And the reason I would argue that Yoshi becomes a property of Mario when Mario gets Yoshi is because, like, to actually perform the programming work of having two entities coupled in that manner, two independent entities coupled, both in terms of the physics and everything else, you'd be able to see the jank. It would look like a bad Unity game, right? Like Mario's physics wouldn't quite follow Yoshi's physics and that sort of thing because they'd be reacting to each other through the physics engine rather than the smooth animation for which Nintendo is famous, right? Make sense? Question?
Do you know, like, up to what, like, you know, what coordinate do they keep their data? Because I sometimes play, like, Mario and then he was using Luigi, and then, like, the mushrooms, like, and those kind of things were not on the screen, but they were there, like, once I get there. So I'm just curious, like, I don't think they're gonna keep all the data, like, all the way to the end of the map.
Oh, yeah. Yeah, yes. So generally speaking, the way that side scrollers like this will typically work, particularly if the level is sufficiently large, yeah, you'll have a load and an unload zone, which are like, you know, it doesn't even have to be that far from the edge, like from the rendering edge, but like let's just say that it's like this screen, you know. The game will load game assets in chunks. As you're going this way, it loads the next chunk. It keeps loading them forward and then freeing the space behind as you travel this way, which is why if you travel far enough that way and then go back again, in some games you can get enemies to respawn and that type of thing, because the fact of the enemy being killed has been unloaded when that chunk of the level is unloaded. Right? And then when you go back again and it reloads it, right? Make sense? Question?
I just wanted to add, most Mario games have an incredibly small, like, unload range, I guess. I think this one's only 4 blocks. So it's really tiny.
Oh, really?
Yeah.
So apparently only four blocks off, like 4 blocks from the edge of the screen?
I know it was that way in Super Mario World, and they kept it that way in Mario Maker. So I imagine most games are around 4 blocks. And bonus is
There we go. Knowledge. Yeah, so apparently that's quite tight, only for, you know, because with these 3D rendered environments, everything that's not on screen, you're having to pay a pretty high price for maintaining all of those assets anyways, right? So your inclination is to be conservative with them, right? So we've talked about the characters. It's worth noting everything that is currently appearing on this screen is a class of one form or another, right? Everything from the ground blocks to the bricks to the question blocks to the pipes to this spiny that's sort of sneaking in the side, the fruit on the bush itself, because the bush can exist independent of the existence of the fruit. These hills in the background are all render objects, which would be they would have their own game objects attached to them. Or they would be not attached to them. They are game objects, right? The skybox that's being rendered is a game object, right? Yeah. Yeah, just on the subject of like loading levels. Anybody here play the Metroid Prime games? Oh, come on. On the GameCube? You guys too young for GameCube now? That is so sad. All right, that's almost as sad as the way that Python handles private variables. Okay. It would have been easier if you guys had like direct experience, but like, so, all right, let me see. Let's see here. Get out of here, you. Metroid Prime. Do I have internet here? I do not. All right, anyway, so I can describe it. So it's a 3D game, right? But you have like these these doors between different segments of the levels, and it's like reasonably claustrophobic. But I'm reasonably certain you have to shoot the door to open the door, and sometimes there's a delay between the door opening and when you shoot it. And I think that delay is proportional to the size of the geometry of the next room. So I think that in those games, shooting the door itself is the command to load the next portion of the level. But, you know, it is what it is. Let me just check to see if there's anything interesting on these slides. Not really, okay. Maybe I'll just talk a little bit about attributes in the last minute of class. So with respect to the Marios, you might imagine several properties which any particular type of entity might have. Certainly, X and Y coordinates are a big one, you know. For an object to be renderable, especially in, in a Mario game such as this one, which is sort of the 2.5D 3D rendered version of Mario's, you would have X, Y, Z coordinates, obviously. Objects which are capable of physical motion would have, momentum and speed and acceleration variables. You would have, various attributes related to, state that the player interacts with. Has a coin been picked up, right? It might be picked up briefly before it's deleted. It might enter that state. If you consider question marks, question mark boxes, they have a used and unused state, which would of course be indicated by a variable. In general, this is generally not how movement works in any game that's any good. When you request movement from a player character, ordinarily you will perform some kind of modification to that player's, you would model a virtual force on the character, or you would make some kind of momentum calculation. You don't just modify the XY coordinates themselves, because basically at that point that's like giving a big middle finger to the physics engine, and it will not thank you for that. That's a great way to end up inside of a wall. So yeah, anyway. Any questions? Yes. What do I think about the Doom engine?
The one that uses binary space for each.
I haven't dug into the details of it, to be honest. But certainly, if for no other reason, it's interesting from a historical perspective, right? It's like how it's like how 50 years from now we'll have classes on the Havoc engine and stuff, just to study what was improved.